All right, let's get right into it. I want you to imagine building an entire city, a whole society, on top of a giant block of ice. Sounds crazy, right? But for decades, that's pretty much what we've done across the huge northern parts of our world. The very foundations of our cities, our roads, our critical pipelines, they're all built on ground that's supposed to be permanently frozen. But what happens when that permanent foundation starts to melt?
This isn't some far-off hypothetical question. It's a real, tangible challenge we are staring down right now. And as you're about to see, the consequences are, well, they're massive.
And this is what it looks like. This is the reality of that melting foundation. On the left, you see a building being literally ripped apart as the ground sags beneath it. And on the right, that's a highway that's buckled and warped like a piece of ribbon. This isn't a forecast, folks. This is today.
So to really wrap our heads around why this is happening, we've got to understand the ground itself. What exactly is this frozen foundation we've been building on for all these years? Well, it's called permafrost, and the definition is actually pretty simple. It's any ground, soil, rock, sand, that stays frozen solid for at least 2 years in a row. You can think of it as nature's concrete, a subterranean binder holding everything together with ice. And the scale of this stuff is just immense. We're not talking about some small patch of frozen land. Permafrost underpins about 1/5 of the entire land surface in the northern hemisphere. It is a huge part of our planet's structure. But here's the problem. This permanent frost isn't so permanent anymore. Since the 1980s, its temperature has been climbing, in some places by as much as 1 degree Celsius every single decade. And as it warms up, that solid-as-a-rock foundation gets dangerously close to its melting point. So how exactly does a warming trend translate into roads collapsing and buildings cracking? The science behind it is honestly both fascinating and a little bit terrifying. The physics of it are surprisingly straightforward. When permafrost is frozen, it has what engineers call a high bearing capacity. Basically, it's super strong, stable enough to hold up a heavy building. But when the ice inside it melts, that solid ground turns into a weak, unstable, waterlogged slurry. Kind of like mud, that can't really support much of anything at all. And there's a specific scientific term for the bizarre, chaotic landscape this process creates: thermocast. It's just a fancy word for what happens when ice-rich permafrost thaws out, causing the ground to sink and collapse unevenly. It creates all these pits, mounds, and huge stretches of completely unstable terrain. And this is what thermokarst looks like in the real world. I mean, look at this. This isn't a sinkhole from a disaster movie. The ground has just given way, completely exposing the ice and soil that were frozen beneath. And see that vehicle nearby? That gives you a sense of the incredible, mind-boggling scale of this collapse. The effect this has on our engineering is staggering. In some Russian Arctic cities, the load-bearing capacity of the ground has already dropped by more than 40% since the 1960s. The foundation is literally weakening right under their feet. Okay, so we've covered the science. Now let's actually see the damage. We're going to take a quick tour across the north to witness the real-world consequences of this collapsing ground. First stop, Russia, which is home to some of the largest cities ever built on permafrost. You can just see how this building is twisting and crumbling. In cities like Vorkuta, it's been reported that up to 80% of buildings are showing some kind of deformation because the ground beneath them is thawing. 80%. Now let's hop over to North America. Here, it's often the long, linear things, our roads, our pipelines, that are especially vulnerable. This is the Alaska Highway, and the ground is literally slumping away, tearing the road in two. Maintaining these vital arteries is becoming a constant, incredibly expensive battle against the thaw. And this problem isn't confined to the far north either. Way up on the high-altitude Qinghai Tibet Plateau, they call it the roof of the world, warming permafrost led to this, a catastrophic bridge failure. When the ground starts to move, our most critical connections can just break. After seeing those images, this number really hits home. And listen to this. This is for just one territory in Canada. $41 million in damage every single year. Now, just try to imagine multiplying that cost across the entire circumpolar north. The financial toll is absolutely staggering. As bad as all that is, the damage we're seeing right now is really just the beginning. Let's take a look at what scientists project is coming down the pike as the world continues to warm. This map paints a pretty stark picture of the hazard potential by the year 2050. All those areas shaded in orange, that's where thawing permafrost is expected to pose a high risk to infrastructure. And you can see, This is a truly circumpolar problem, affecting huge areas of Russia, Canada, Alaska, and even Scandinavia. And if you want to put a number on that risk, here it is. By 2050, projections show that a jaw-dropping 40% of all critical infrastructure across the Arctic, we're talking roads, buildings, pipelines, the works, will be in these high-hazard zones. 40%.
And this isn't just about infrastructure. It's about people and their homes. Projections also show that by 2050, 42% of all the permanent settlements in the entire permafrost region will be in areas facing extreme instability as the ground beneath them completely thaws. Whole communities are at risk.
But it's not all bad news. The challenge is obviously immense, but it's being met with some pretty incredible human ingenuity. So let's look at how engineers are actually fighting back against the thaw.
This table shows just a few of the brilliant solutions people are working on. At the more expensive, high-tech end, you've got these things called thermosiphons. They're basically passive pipes that cleverly use the cold winter air to suck heat out of the ground and keep it frozen. But then, on the lower cost end, you have something as simple as using high albedo, or highly reflective surfaces, basically white paint, to reflect sunlight and keep the ground underneath just a little bit cooler. It's a fascinating mix of really advanced tech and common sense.
Now, clever engineering is a huge part of the answer. But the real path forward is going to require a much bigger shift. It's about changing how we even think about building in the North. It's going to demand better data, more international collaboration, and entirely new ways of designing things. And all of this brings us to the final, absolutely critical question. For more than a century, we built our northern world on one fundamental assumption, that the ground was stable and frozen solid. That assumption is just not true anymore. So the great challenge for all of us in the 21st century is this. How do we adapt? How do we innovate? And how do we rebuild on a foundation that is literally constantly changing right beneath our feet?